Hello everyone, and welcome today to my Pure Math YouTube video. So today I'll be showing you the expansion of trig functions, and I'll also be going into the double angle formula, and lastly I'll just be doing some past paper questions. So these are going to be the foundation towards the next topic, which is the topic of the form a sine theta plus b cos theta equals r sine theta minus alpha. So don't worry about that yet. This is just the foundation, so try to grasp this because we'll be using this in the next topic. So let's start. So first of all, what is the expansion of a trig function? So I'm going to show you, for example. So here's one that you need to know. Sine a plus b. So we have a formula for this, or rather an expansion for sine a plus b. And what this is sine a cos b plus, following the sign that's here, these two signs have to be the same in this situation, plus, and now we're going to invert which one's first. So in the first one is sine a cos b, so in the second one it will be cos a sine b. Okay, and that's the very first one that you need to know. Try looking at it a little bit, try to remember it, and I'm sure it'll be pretty good to know. You're going to need to know this. This is a foundation element of the whole topic, so try to remember this. And well, what would happen if the sign inside the bracket wasn't plus? So let's say it was sine a, well, sine of a minus b. Well, in that case, since we know we have to keep the signs the same, it will be sine a cos b minus cos a sine b. Please notice that these two signs are the same when it deals with sine. So for expansion of sine, the sign is always the same. Try to remember that. So let's try an example with this. We're going to go at them one at a time. We'll do each example, and then hopefully by then you'll be kind of getting the concept. So we want to show, so I'll give us a question here. The question says, show that sine of x plus pi over 2 is equal to cos x. Now remember the magic formula. In this case, this is in the form sine a plus b. So we can rewrite this with just the form. So we'll say sine a plus b is equal, and we know from the formula that we should have just swatted. What is the formula? Think about it. If you haven't been able to just get it right so far, please just go back in the video, look at it one more time, and remember it. Active recall is very important. So in this case, it's just sine a cos b plus cos a sine b. And yeah, so let's go. So now we know that a in this case, a is equal to x, and the b is equal to pi over 2. I'm just taking these from here, right there, from where it was in the brackets. The first one, we'll just say the first one's a and the second one is b. Okay, so now let's actually substitute our values. If a is equal to x and pi over 2 is equal to b, we'll have sine x, and it will be multiplied by cos of pi over 2, and then plus cos x times sine of pi over 2. Now if you see cos of pi over 2, you can put this into your calculator. Cos pi over 2. Oh wait, actually please ensure that your calculator is in radians. Cos shift pi, because if it's not in radians then it won't actually give you the value that you're looking for. Cos pi over 2 is 0, so it'll be sine x times 0 plus cos x times, well, sine of pi over 2, if you put that into your calculator, over 2 is just equal to 1. So this way, we know that this is equal to cos x, and that's equal to the right hand side. because that's what the question had actually asked us to prove. The question asked us to prove that sine x plus pi over 2 is equal to cos x. And after using the expansion sine a plus b equals sine a cos b plus cos a sine b, we were able to prove that. And that's a very simple example, but it actually does happen, especially on paper 1 exams. I don't think you'll get something as simple just in that form in a paper 2, but definitely paper 1s, because I was practicing and saw a lot of those. So let's move on. Let's say it's not sine. What if it's cos? So if we have cos A plus plus B, as I would say, plus cos B plus B, what will this be equal to? Well, in the terms of cos, cos is a little bit different than sine. So for cos, we're going to change it up a bit. So if you remember for sine, sine has it where we have sine and cos being multiplied together. But in this one, cos is going to multiply it together by itself, and sine is going to be multiplied by itself. So in this case, we'll have cos A, cos B, and then for cos, remember for sine, the signs are the same, but for cos, the signs are not the same. So instead, it'll be minus. So if you see a plus in cos, it'll be minus sine A, sine B. Okay? So that's the key difference between sine and cos. For cos, you'll have both cos terms on one side and both sine terms on the other side. Okay? So that's just how it is for cos. And let's say now we had cos of A minus B. Well, in this case, it's just going to be equal to cos A, cos B, and since this sign we know this sign has to be the opposite of what's in the brackets, it will be plus positive sine A, sine B. And these are just the two things you have to remember for cos. You have to remember these for sine and cos. Find a way to remember them. Normally people can put them in a generalized equation but I think the generalized equation, if you don't know how to read it, is a little bit harder because of the placement of the minus sign. So just to make it a lot simpler, I want us to just remember them individually. It shouldn't take too much brain power. Hopefully you're getting that. So let's say we wanted to evaluate, or the question, we had a question and it said, show that cos of pi over 2 plus x is equal to minus sine x. Well, how would we do this? So we want to expand it using the expansion that we just learned. Okay, so we just learned that cos A plus B is going to be equal to cos A cos B. And we want to remember that the sign here should be the opposite of the sign that's in the brackets. Always remember that. Minus sine A, sine B. Okay, and now we know that based on their positions, we'll say the first one's A and the second one is B in this case. So here's A and here's B. And so we're going to just plug that in. So A is equal to pi over 2 and B is equal to x. So in this situation, cos pi over 2 times cos x minus sine pi over 2 times sine x. Okay, if you don't understand what's going on so far, well, we have the general expansion right here, and we know that in the form of a plus b, where a and b could be any kind of values, we get this. We expand and we get this cos a cos b minus sine a sine b, and that's when it's positive. We always have to remember to flip the sign, and we're good. And that's how you remember the cos one. But now put this into your calculator. We're going to go back here. Well, before we get there, all I did was I took the a value and the b value that were given in the question. Well, they didn't tell us it was a and b. We had to infer that much. And I substituted them into the actual equation. Now in this equation here, well, not equation, but in this here, I didn't have any multiplication signs. So that's the only thing different here. I just put the multiplication signs here so that it's easier for you to see what's actually going on. They're being multiplied rather than putting them together. But in this one, they're still being multiplied. Just keep that in mind. So when you put that into your calculator, or if you still remember from the last example, if you put cos pi over 2 in your calculator, you'll get 0. So we know that this whole left-hand side has to be 0 because anything times 0 is 0. So we'll have 0 times cos x minus sine of pi over 2, which we know sine of pi over 2 is actually just 1. So minus 1 that is multiplied by sine x. Now remember, these two things are being multiplied, so we don't have minus 1 plus sine x. It's minus 1 times sine x. It's minus 1 times sine x. So this cancels out because it's 0 times whatever is 0. So we'll just be left with negative sine x. And that's going to be equal to the right-hand side, because this is what the question had asked us to prove, actually. So the question asked us to prove that cos pi over 2 plus x is equal to negative sine x, and using the expansion we were able to find that. This is a trick to learn all of the values for sine theta and cos theta that you'll probably need to know. So let's imagine you have a hand. I'll just put fingers down a little bit so you can see that they're individual fingers. These almost look like toes. So you can just write them down. So you can say this is 1, 2, 3, 4, 5. You have 5 fingers, you know that much. Or hopefully you do at least. And, well, we'll just call these different angles. So let's say the first finger is 0 degrees. So let's say the second finger is 30 degrees. Third finger is 45 degrees. Fourth finger is 60 degrees. And fifth finger is 90 degrees. Now, you'll be wanting to know these types of degrees very often, so these are the most commonly used degrees. So it's advised that you at least know these, especially for the question that asks with no calculator. If you don't have a calculator that deals with surds properly, it might be hard for you to know, or you just have to remember it. So let's say we wanted to find sine of 45 in relation to surds. So we go from 0 here, and we go over 1 to get to 30. And we jump 1 over to get to 45. So we'll have sine of 45 degrees is equal to, so we count the number of fingers that we jumped. So if you notice, to the right of 45 is 1, 2 fingers. So what we're going to do is we're just going to take the square root of that, so it's going to be root 2 over 2. So for any of these, you're just going to instantly want to put a root on the numerator and divide it by 2. And this works for anything. So let's say, for example, you wanted to find sine of 60 degrees. So if you follow that same example I just had, so you look for 60 degrees. 60 degrees is right here. And then you look at the amount of fingers to the right of that 60 degrees. So 1, 2, 3. And what we're going to do with that is we're going to instantly square root the 3. So root 3, square root of 3, over 2. And hopefully you're getting the hang of it by now. Okay? So another example, if you wanted to find sine of 90, well, we look to the amount of fingers on the right side of 90. So 90 is right here. The right side of 90 is everything that way. So we see how many fingers are to the right of 90? Well, 1, 2, 3, 4. So instantly we're going to have root 4 over 2. But root 4 is just 2, so it's going to be equal to 2 over 2, which is just equal to 1. Okay? And this is the way that you can know the value of these if you don't have a calculator that has search to decimals, like that conversion, because I don't actually have one of those. Well, not yet. And yeah, so that's what you do for sine. But, well, what if you want to do for cos? Well, if you wanted to do for cos, it's actually essentially the same thing. But instead, for cos, if you wanted to find, for example, cos of 30, for cos, you don't go to the right side, you go to the left side. So you look at the amount of fingers on the left for cos. So if you wanted to find cos of 30, this would be equal to, look how many fingers are to the left of 30. Well, 1, 45, 2, 60, and 3, 90. So we're just instantly going to square root it, so root 3 over 2. Okay, and let's say you wanted to find cos of cos of 0. So if you found cos of 0, well, how many fingers are to the left? 0. Well, we have, oh, I keep on erasing this. So the amount of fingers to the right of 0 are 1, 2, 3, 4. So it's going to be root 4 over 2, which is equal to 2 over 2, which is equal to 1. So cos of 0 is equal to 1. And one last example I'm going to give. If you wanted to find cos of 60, well, you look cos of 60. And 60 could also just be cos of pi over 3. So you could also use it in radians as well. So don't just only think it's in degrees. Well, this is just equal to, look how many are to the left of this finger. So it's just 1. So we'll have root 1 over 2. And the square root of 1 is just 1. So we're just equal to a half. And that's a neat little trick that you can use to actually remember the surds equivalent of the trigonometric functions, or well, more specifically sine and cos. This will be very helpful, especially for past paper questions which asked about no calculators. They ask for you to not use a calculator, so that will be very helpful. Let's find the exact value of sine pi over 12. Well, how would you go about doing that? Well, we don't really know how to just evaluate that. Well, and they want us to do this without a calculator, that is, okay? So if you want to do this without a calculator, but we don't really know what's going on with that, right? We don't actually know. So what we're going to do instead is we're going to see if we can break this pi over 12, this right here, into a form that's easier for us to work with. Okay, so coming back now, so let's say we have sine of pi over 12. Well, pi over 12 is the same thing as saying pi over 3 minus pi over 4. Okay? And if you don't believe me, you could just work that out. And you'd get this same answer. You get pi over 3 minus pi over 4. So this way, if these two things are equivalent, that means we could use the one with a negative sign in place of this pi over 12. So instead we'd be left with sine of pi over 3 minus pi over 4. And now we have it in a form that we can actually expand, because we remember that sine A, oh sorry, it should be in brackets, sine of A minus B is equal to sine A cos B minus, because remember these two signs should be the same, minus cos A sine B. Okay? And in this case, we'll just say the first one's A and the second one's B, so we'll have sine of pi over 3 times cos of pi over 4 minus cos of pi over 3 times sine of pi over 4. And now all you have to do is remember how recall these kind of I forgot what you'd call them, but recall these values. So if you don't already know, I'll post a video just above this, and it will be me showing you a cool trick on how to remember these trigonometric things. Okay, if anything, I'll just add it to the beginning of the video, that way it'll be a little bit easier for you to remember. So pi over 3, as we know, 1 pi is just 180 degrees, so that means pi over 3 is 60. So that means that we want to find sine of 60. Okay, so to find sine of 60, we're going to quickly take a brief intermission, and I'll show you a quick little way that we can find it. Instead of going to another video, we'll just show you here. So this is the finger method. Oops, you know what, no, we won't be doing that. So sine of 60. So if you put sine of 60 in your calculator, sine of 60, well, That's assuming you have a good enough calculator. But sine of 60, 0, 30, 45, 60, is just equal to root 3 over 2. So this right here can be replaced by root 3 over 2, multiplied by cos of pi over 4. So we know pi is 180, so cos of pi over 4 is going to be equal to, well, pi over 4 itself will be equal to 45 degrees, and cos of 45 is 0, 30, 45, so it's root 2 over 2. Okay, so now we're multiplying these two, and then we'll have minus. Now cos of pi over 3, where pi is 60, so 0, 30, 45, 60. This will just be root 1 over 2, or a half, minus a half, times sine of pi over 4, which is 45, 0, 30, 45, 1, 2, which is root 2 over 2. So now we can just multiply these out, or actually, we see something that isn't common to both of them. So we can pull this out and factor it out, so we'll have root 2 over 2 times, and what can we multiply this by? Well, actually, we could even make this a little bit different, actually. What we could do is we could say, well, no, we'll just do it this way. Root 2 over 2 multiplied by root 3 over 2 minus 1 over 2. And this is how we would evaluate it without having a calculator, and that's exactly what the question would have asked you to do. So in the intro of this video, I'm probably going to take a little cut in the video and I'll show you the method that I use to do these rather than just memorizing. And yeah, so I'll show you how to do that, and it will be kind of in like in a separate recording, but don't worry about that. So we're going to move on now to the expansion of cos. Let me get a different color. Did I do green already? I did green already, so I guess I'll go to yellow. So let's say we have tan of A plus B, and we want to find what that is. Now, since I already taught tan sine of A plus B and cos of A plus B, why don't we just derive this by ourselves? So we know that sine over cos is equal to tan. And this holds true for this, actually, for this expansion. So this tan A plus B is going to be the same, is going to be the same as sine A plus B over cos A plus B. Okay? Now, we're going to take this and we're going to work with it a little bit more. So we can expand sine A plus B using the expansion formula. So sine A plus B is just sine A cos B plus cos A sine B. And this will be over. Now when we expand the brackets for cosine, it will be cos A cos B minus sine A sine B. Okay? And now what we want to do is, this might seem a little bit unintuitive, but we want to get a bunch of tans. So how do we get tan? Well, we get tan by dividing sine by cos. So what we're going to do is every single term here, we're going to divide it by cos. Well, we're going to more specifically cos A, cos B. Okay? Because we're trying to get everything to be in terms of tan. So to do that, we just have to divide everything by cos A, cos B. So what this will be equal to is sine A cos B, and this will be divided by cos A cos B plus cos A sine B over cos A cos B. So remember, we're just doing this because we want everything to be in terms of tan. It might seem a little unintuitive, so I'll just write it in bubble here. If you're not getting it, you can write here. So divide by cos A cos b. This way we can get everything to be in terms of tan. And don't forget, there's already a denominator, so it'll be over cos a, cos b, over cos a, cos b, minus sine a, sine b, over cos a, cos b. I've been saying cos so much, and this might look like madness to you right now, but hopefully you're understanding. And we can simplify this now. So we'll work with the numerator first. So if we have sine a cos b over cos a sine b, okay? So sine a cos b over cos a sine b, what is that equal to? So sine over cos and cos over cos. So we know that cos over cos is just 1. So this is going to be equal to sine over cos is tan. So we'll have tan a times 1 plus, in this situation over here, it's the same thing. Cos a over cos a is the same thing as 1 plus 1 times sine b over cos b is just tan b. Okay? And this will be divided by, on the denominator here, cos a cos b over cos a cos b is just 1 minus this over here. And sine a over cos a is tan a. And sine b over cos b is tan b. And that's the identity. Now to make it a little neater, I'm going to just kind of rewrite it. So we'll have tan a plus tan b over 1 minus tan a tan b. And that's exactly how it is. Now, here's the thing. What if we wanted to do it for, well, sorry, this is going to be equal to tan of a plus b. Now, what if we wanted tan of a minus b? So I'm not going to spend the time to re-derive this, because hopefully you're getting the derivation. Tan a plus b, tan a minus b is just going to be tan a minus tan b over 1 plus tan a tan b. So the trick for tan is that when it's negative, the numerator has a negative sign, and the denominator has a positive sign. And when it's positive, the numerator has a positive sign, and the denominator has a negative sign. So that's just something to take into consideration. Great. Now that you've made it to this part of the video, we'll be continuing on with a little bit more challenging stuff. Well, I wouldn't say challenging, but you'll have to use your brain a little bit more. So what am I going to do now? Well, we're going to be moving into double angle formulas. So let's say we had sine of 2 theta. Well, the double angle formula for this is just equal to 2 sine theta cos theta. Now this is something you need to memorize. Just try to remember this. Sine 2 theta is equal to 2 sine theta cos theta. 1 second, I'm going to have some water. Wow, it's already been 24 minutes. And that's all you have to know for sine. When there's a double angle formula, that's what the sine is. So let's say we had cos 2 theta. Now if you thought your life was going to be easy right throughout this video, well, you were sorely mistaken. Not that this is hard, but cos 2 theta actually has 3 different values. Well, not values, but you can represent it 3 different ways. Now 3 ways to represent this are cos squared theta minus sine squared theta. Another way to do this is also 2 cos squared theta minus 1. And lastly, the last one is 1 minus 2 sine squared theta. So these are the values, or well, the ways we can represent cos 2 theta. It has 3 different ways. Just try to remember these. I won't be showing the derivation for these. Just try to remember them. If you can remember them, that would be great, because I'm going to just go right into examples with hardcore applications so you can actually apply them and see how they're used in real time. Okay? Okay, great. Okay, so lastly, what if we had tan of 2 theta. Well, this is just going to be equal to 2 tan theta over 1 minus tan squared theta. Again, you're just going to want to memorize these. I don't remember if they come on the formula. I don't think they come on the formula sheet. The only thing I saw on the formula sheet really were like products of sums and differences, but I might be wrong, so don't hold me to that. But it's always good to know these things. So try to memorize these. I'll just leave it on the screen for a second. You can pause the video, memorize it, look at it, memorize it, and then unpause the video because we're about to start doing some questions. So moving into the questions now. So for questions, we'll have this first question. So what if we had express cos 3 theta in terms of cos only? So they wanted to have a single angle. We don't want any double or triple angles or whatever is going on there, okay? So what could we do for that? So we don't know what cos 3 theta is, but we know that cos 2 theta could be expanded, right? But we also know that if we wanted to break this 3 theta into two parts, we'll have cos of 3 theta, well, cos of 2 theta plus theta, because this is just the same thing, because 2 theta plus theta is just 3 theta. So we can break it down this way so that we can actually work with it. Okay, great. So now that we actually have this form in cos a plus b, we know that we can expand cos a plus b and go from there. So when expanding this, we'll have cos 2a, or cos 2 theta, times cos theta, and it has to be the opposite sign. Remember, opposite sign, don't forget that, minus sine 2 theta times sine theta. Now, we just learned that cos 2 theta can have many different values. Oh, sorry, not values, many different ways that it can be represented. Okay, so what do you want to do here? Well, since everything deals with cos theta so far, well, I guess we could use the one that has 2 cos theta. So one of the double angle formulas for cos is 2 cos squared theta minus 1 times cos theta minus sine 2 theta, we know, is just 2. So right here, I'm just expanding this, 2 sine theta cos theta times sine theta. Great. Now, if we expand these brackets and these and multiply over here, what our final thing would be is 2 cos cubed theta minus cos theta minus 2 sine squared theta cos theta. So we just multiplied sine by sine here, and we just still had the cos. So this is what we're having so far, and you definitely should get marks for this so far already. But now we said earlier that we wanted everything to be in terms of cos. So how could we do that? So we have sine squared theta here. Now this is definitely not cos. So from the fundamental identity that I keep on bringing up, cos squared theta plus sine squared theta equal 1. Well, sine squared theta, if we were to transpose for it, sine squared theta equals 1 minus cos squared theta. And this is how we could relate sine squared theta and cos squared theta. So in the end, we could have 2 cos cubed theta minus cos theta minus 2 times 1 minus cos squared theta. And this will be multiplied by cos theta. Now we essentially have the answer in our grip right now. We have it so close. We're just going to work on it just a little bit more. So we're going to expand these brackets over here. So minus 2 times 1 is just going to be minus 12. Well, yeah. Yeah, actually. So minus 2 times 1. Wait, did I do something weird? Oh, no, I didn't. Okay, great. Great. So we'd have minus 2 plus 2 cos squared theta, and this would be multiplied by cos theta. So this is going to, if we expand this further, because we're still multiplying, we'll have minus 2 cos theta plus 2 cos squared theta. And what we had before was 2 cos cubed theta minus cos theta minus 2 cos theta plus 2 cos squared theta. Now we can simplify this just a little bit further. And yeah, we can do that and our life will be good. So we'll have 2 cos cubed theta with dealing with these now. Minus cos theta minus 2 cos theta is just minus 3 cos theta. Wait, sorry, this is cos cubed theta now. I made a tiny error. Sorry about that. This is actually supposed to be cos cubed theta, cos cubed theta. I just realized I forgot to expand that properly. So it should be plus 2 cos squared theta times cos theta, and yeah. Great, so now we can add these, so we'll have 4 cos cubed theta minus 3 cos theta. And if you realize this is in terms of cos theta alone, which is all we wanted to do. So great, so we were able to solve that question. We were able to express cos 3 theta in terms of theta alone. So that's great. Okay guys, welcome to the past paper section of the video. So this is going to be from June of 2019. So they asked us to prove the identity tan A plus B minus tan A equals sin B, over cos A times cos of A plus B. So if you notice, the result that they want is actually in terms of sine and cos. So we know that tan can be expressed in terms of sine and cos, so let's just immediately replace tan A plus B with this sine and cos equivalent. So we know tan A over tan, so we know sine A over sine B. Sine A over cos A is equal to tan A. So tan A plus B is just equal to sine of A plus B over cos of A plus B. Okay? And minus tan A is just going to be equal to sine A over cos A. Now, if you notice in the denominator of the answer that we should get, it has cos A plus B. So we'll probably not expand the denominator right now. But what we can expand is the numerator, because the numerator will only have one value. So let's do that right now. So sine A plus B expanded is just sine A cos B plus cos A sine B over cos of A plus B. And this will be subtract minus sine A over cos A. Great. Now, what can we actually do? Well, we can actually just subtract these things. So what is the LCM, or I don't even remember if it's LCM or HCF. I don't remember what we do for this. But what can go into both of these? Well, neither the denominators cannot be the same. So we're just going to multiply them. Great. Now, how many times does sine A, how many times does this numerator, I won't say it out loud, but how many times does this numerator go into this denominator? Well, it goes in there cos A times, right? So what we'll have is we'll have cos A, and this will be multiplied by sine A cos B plus cos A sine B minus, now how many times does this go into this? This goes 1, so we'll be multiplying this denominator by this numerator. So we'll have minus cos of A plus B times sine A. Okay? So that's how it is so far. We're going to now expand the numerator. So this is a lot to look at so far, I know. It looks like a lot to look at, but everything can be broken down into simplest form, which is probably the form that you know most. So don't overthink it, just break it down. So if you want to expand these brackets, you have to multiply it by what's inside the bracket. So when you do this now, what will you get? Well, you have three terms in here. So you have sine A times cos A. Remember, you can't multiply cos A times cos B to get cos squared. You have to just multiply them together. So cos A times cos B plus cos A times cos A is just cos A squared. So cos squared A times sine B. And it will be subtracted from. Now we know that cos A plus B is just equal to cos A cos B minus sine A sine B. And this will be multiplied by sine A. So now when we expand this, we'll have minus sine A cos B minus sine squared A sine B and now when we distribute the negative sign, we'll have minus sine A cos B, and negative times negative is just positive, so it's plus sine squared A sine B. And over here we'll have sine A cos B plus cos squared A sine B. I know this question seems really rough, especially for the first practice question, especially if you're not really getting it so far. But hopefully if you just replay the video, you'll be understanding a little bit better. So let's continue. So what do you notice here? Well, we have sine A cos B minus sine A cos B. So, well, we can just cancel this out. So this cancels out. So what we'll be left with is cos squared A times sine B plus sine squared A times sine B. And please remember, this is all still over at denominator. The denominator is cos A times cos of A plus B. But we're not worrying about the denominator right now, because if you notice in the question, the denominator is already what it should be in the answer. So we won't be expanding anything with the denominator. We're just going to expand how we know. So what is common between cos squared A sine B and sine squared A sine B? Well, sine B is being multiplied in both of them. So we'll take that out. So we'll have sine B, and then we'll multiply it by cos squared A plus sine squared A over cos A times cos of A plus B. Now if you notice, this is actually in the form of the fundamental trigonometric equation, which is equal to 1. So what this is equal to is just sine B times 1 over cos A times cos of A plus B. Oh wow, this is a lot of talking, I can't lie. Yeah, but nevertheless, this is actually what they want us to prove, so this is just equal to the right hand side. I'd advise that you write down these questions, because I won't be able to keep the question itself in the frame at all times because I'm writing and going down. But if you notice, we were able to prove that's equal to the right hand side. So when you get a question like this, sometimes you might not get it on the first try. Like for example, you might swap tan A plus B and actually expand the brackets. I'm not sure if you could get it that way. You could probably get it that way, but this way is just a lot easier. And so never give up when it comes to trigonometry. Always just keep trying something new, and eventually there will be something that works. So yeah, just take that into consideration. So we're going to be moving on now to our next past paper question, which is from June of 2018. Now this question seems a little bit rougher now. It has a lot of double angle formulas, and it wants us to prove that it's equal to sec 2 theta and tan 2 theta. And you're probably wondering, well, you don't even know what that is. You don't even know what sec 2 theta is. And that's right, we weren't really taught it. So I'm going to go through it. I just need to have a sip of water. Okay, now that I've rehydrated myself, we can actually write this question. So in this case, right, what we can do is we could actually just expand these. So we have sine 2 theta minus cos 2 theta plus 1 over cos 2 theta plus sine 2 theta minus 1. Don't worry about the right hand side just yet. We're going to just focus on the left hand side because it has more information and we can do more with it. So right now, let's just try to expand everything that we want, okay? So we have sine 2 theta. We know that sine 2 theta is equal to 2 sine theta cos theta minus cos 2 theta. Well, in this case, what we could use is the is anything that deals with sine theta, because, well, that seems to be pretty common. We could definitely factor it as sine theta, looking at it right now. So because there's a sine theta in this term, we can use the one with sine theta, so we'll have minus, and cos 2 theta in terms of sine theta is just 1 minus 2 sine squared theta plus 1. And this will be over cos 2 theta. Now in the denominator, we're going to have plus, I'll just do the sine 2 theta for 1 first. So we'll have 2 sine theta cos theta. If you don't know where this is coming from, I'm just expanding this one first because it's easier, because cos 2 theta has 3 options. And yeah, that's a bit harder to know which one to go for. Okay, so which one could we use here? Well, this one, since it's the denominator, and we could definitely factor out a cos theta here. We could use the trigonometric. Well, we could use what could we use here? We could use 2 cos squared theta minus 1. So 2 times cos squared theta minus 1. We'll sub that in for cos 2 theta. If you don't remember that, please go back in the video. I have timestamps in the description, and you can go back and just look at them, write them down in your notebook or whatever, and just keep it there so you can actually use it. Now let's actually work this out. So we have 2 cos squared theta minus 1 plus 2 sin theta cos theta minus 1 on the denominator. So there are 2 minus 1s here, right here. So we can actually work with them. So what we'll have is well, over, we haven't done the numerator yet, but it'll be over 2 cos squared theta plus 2 sine theta cos theta minus 2. We got the minus 2 from just subtracting both of the negative ones. And for the numerator now, we can expand this negative sign to these things. So it'll be minus 1 plus 2 sine squared theta. So we have 2 sine theta cos theta minus 1 plus 2 sine squared theta plus 1. Now the minus 1 and plus 1 will cancel out, leaving us with 2 sine theta cos theta plus 2 sine squared theta over 2 cos squared theta plus 2 sine theta cos theta minus 2. Now, this is a lot of cos thetas and sine thetas, but try to stay with me. Now, in the numerator, what could we factor out? What is common to both of these terms? Well, it's sine squared theta. It's sine theta, actually. Yeah, because sine theta is in both terms. So we could factor out 2 sine theta. So 2 sine theta. And in the brackets, we'll have cos theta plus sine theta. Okay, so for the denominator now I want you to stay with me, okay? We're going to work some mathematical magic. I guess you could say it's kind of cheesing the question a little bit, but we're going to be working with some mathematical magic. Okay, that's what I'll call it. I won't call it cheesing the question. I'll call it magic. So for the denominator, we'll have 2 cos squared theta plus 2 sine theta cos theta, right? and we have minus 2. But minus 2 is the same thing as minus 2 is equal to minus 2 times 1. And, well, what in trigonometry do you know is equal to 1? Well, 1 is equal to sine squared theta plus cos squared theta. So we could just say this is minus 2 times sine squared theta plus cos squared theta. I know, it's kind of rough to see that on your own. Definitely kind of cheesing the question, but it definitely works because it's true. And now we can expand these brackets. So this will give us minus 2 sine squared theta minus 2 cos squared theta. And we already had 2, I'm sorry, I'm just rewriting everything that was already on the denominator. And great. Well, now what can we do? Well, if I just look at this so far, is there anything that we can cancel out? Yes, there is. Minus 2 cos squared theta plus 2 cos squared theta. Right? So now this whole thing becomes is equal to 2 sine theta, because this is a numerator again, times cos theta plus sine theta over 2 sine theta cos theta minus 2 sine squared theta. Now we have something very similar to that was on the numerator. Now if you notice, the sine theta is common to both, so we can factor this out, and that would give us 2 sine theta times cos theta minus sine theta. So this whole thing would equal to 2 sine theta times cos theta plus sine theta on the numerator, and on the denominator would have 2 sine theta times cos theta minus sine theta. Whew, this is a lot of writing, that is for sure. Now what can we do? Well, we can just cancel these things out. These two are the same, cancel out, and that's just 1. So now we'll be left with cos theta plus sine theta over cos theta minus sine theta. And what do we want to do here? Well, we want to, I guess you could call it, rationalize the denominator. So if you remember from logs, indices, and surds, if you have something like 5 over root 3 minus 2, you can multiply it by root 3 plus 2 over root 3 plus 2, because the denominator would be a difference of 2 squares. So in the same way here, we can just multiply this by cos theta plus sine theta over cos theta plus sine theta. Now, why do we want to do this? Well, we do this because we want the denominator to be, well, one thing. We want it to be a single thing, because we do not want to have a minus sign in the denominator. So let's continue. So this is going to be equal to cos theta times cos theta is just cos squared theta, and cos theta times sine theta is sine. Expanding this is just like cos squared cos theta plus sine theta squared. That's just going to be the same thing as cos squared theta plus sine squared theta plus 2 sine theta cos theta. And this will be over, when it's a difference of 2 squares, what you can do is you can square the first term and subtract the second term. So the first term squared minus second term. So in this case, the first term is cos and the second term is sine. So following that, we'll have cos squared theta minus sine squared theta. Now we can further expand this. So we know that cos squared theta plus sine squared theta up here is just equal to 1. So we'll have 1 plus 2 sine theta cos theta over, now what do you know about this denominator here? Now if you remember, one of the formulas for cos 2 theta, and this is one of the beauties of math, is when it comes back and gives you the right answer that you've been hoping for the whole time. Cos squared theta minus sine squared theta is the same thing as cos 2 theta. So the thing about trigonometry is you have to be cerebral enough to pick these kind of things up. You don't want to be doing this passively, you want to be looking for every opening. Now the hardest part of this question, I'd say, so far, we haven't solved it fully yet, but the hardest part was knowing that we could actually multiply minus 2 by sine squared theta and cos squared theta. Because that was not intuitive at all, what we did in this step. It was not intuitive, and that's the problem. Sometimes the question will require an unintuitive way of answering. So now that we have this, we can actually split this up. Since it's 1 plus 2 sine theta cos theta over cos 2 theta, we can have 1 over cos 2 theta plus, and what do you realize about this? About 2 sine theta cos theta, it's just the same thing as sine 2 theta. It's going to be sine 2 theta over cos 2 theta. Now if you got a little bit lost, all I'm saying is that 2 sine theta cos theta is the same thing as sine 2 theta, remember from the expansions earlier? So that's all I'm doing. So now we have 1 over cos 2 theta plus sine 2 theta over cos 2 theta. Well, 1 over cos is equal to sec. So that means 1 over cos 2 theta is just equal to sec 2 theta plus sine 2 theta over cos 2 theta is just equal to tan 2 theta. And that's equal to the right hand side. I won't lie, that part with the minus 2 times sine squared theta plus cos squared theta, that is a bit ridiculous, but it's what we have to do well in math, okay? So hopefully you get used to it. If you do a lot of the past paper questions, it should help you. And yeah, we'll be moving on to the last past paper question of the video. Nice. Now if you realize, we have actually already done a past paper question. I knew this was a past paper question, so I ensured to do it with you before, showing you how to explain, well, showing you how to prove this identity. So when we got to the 10th section, we actually had to prove it. And this past paper is for, it doesn't say, but I have it on my Notion board. I'll just write it in here for you. It's from 2017. So if you ever want to go and check these past papers on your own, you're free to do so. Well, of course, you have free will. So let's do this. So tan A plus B is the same thing as what? Well, tan A plus B is just equal, so this is just equal to sine A plus B over cos of A plus B. And great, now we have that, so what do we want to do with this? Well, what we want to do is we want to actually expand this. So sine A plus B, expanding this as on the numerator, is going to be equal to 2 sine A cos B over, sorry, sine A plus B, this is not a double angle formula, I'm so sorry. Sine A plus B is just going to be equal to sine A cos B plus cos A sine B. Sorry, that last question really took a toll on me, I won't lie. Over this now, this in the denominator is going to be cos A cos B, and remember the sign has to be the opposite of the one in brackets, minus sine A sine B. Whew. And now we're getting somewhere. So do you remember what I told you that we'd want to do? We want to divide everything. So we're going to divide by cos A cos B, because we want everything in terms of tan, and we know that sine over cos is tan. So we're going to divide everything by cos A cos B. So this is going to be equal to sine A cos B over cos A cos B plus cos A sine B over cos A cos B, and this will still be divided by cos A cos B over cos A cos B minus sine A sine B over cos A cos B. Now, by the time you're done watching this video, you're probably sick and tired of hearing cos A, cos B, cos sine A, all this stuff, all these shenanigans. But now we have it in the form, we essentially have the answer, we just have to simplify it now. So sine A, we'll work with the numerator first. So sine A over cos A is tan A, and cos B over cos B is just 1. So we'll have tan A times 1. We won't write the 1 though, because anything multiplied by 1 is just itself. And then over cos A, which is 1 again, multiplied by sine B over cos B. Now this time is plus tan B. Over, on the denominator now, we have cos A times cos A, that's just 1, and cos B times cos B is just 1 as well, so we'll have 1 minus, and in this case we have sine A, sine B over cos A, cos B. This is just going to be equal to tan A, because sine A over cos A is tan A, and sine B over cos B is tan B. Therefore, we have shown that tan A plus B is the same thing as tan A plus B over 1 minus tan A tan B. Great. Now, hopefully you have understood that. It was a pretty hectic video for such seemingly small content. It was definitely a lot to do. This isn't going to be intuitive if you don't practice it, so I'd recommend practicing a lot. Use a textbook, use any questions your teachers give you, and be ready for this on the exam, because they can bring it in any way. In fact, this came on my exam, which I just sat, and well, not this exact question, but a question like of this type came, and it was actually kind of rough. I won't lie. I was struggling in the exam to do that, especially module 3. Module 3 was the worst. But anyways, if you've enjoyed these videos so far, you can feel free to check out my playlist, because I have a playlist going through all of the CAPE Pure Math syllabus. I'm currently redoing everything that I have done before because I wanted to up the quality. I think that my previous videos I taught a lot less, and instead I was just trying to get you guys to know the content, but now we'll be actually going through and teaching. So hopefully this was helpful to you. Goodbye.